Welcome to Ask and Learn.
All right, so if we wanted to write the electron configuration for silicon, remember how our periodic table is set up with respect to our electron configurations, in the sense that we have the first two columns of the periodic table are the S block, where the transition metals are is D. On the right side is P, except for helium, which is also an S. So if we want to get to something like silicon, which is right about there on the periodic table, we have to first read the periodic table like a book in terms of writing out its electron configuration. So we can look at the row we're in. And we want to get to number 14 on the periodic table. We need something with 14 electrons. So if we read it like a book, we go the first row, and there's an S electron there and an S electron there. So we have one S, two. Then we go to the second row, and we have one here and one here. That's in the second row S area, so 2S, and it's 2 across, so we have 2. Then we keep going over to the P block over here, and that's 6 across, and we have to go through it to get to silicon. So we're going to say 2P6. We come back over to the third row, and we have 2 S's, 3S2. Now, there is no D block for the third row. And so we get over to the P's, and we're going to go over 2 to reach silicon. So that's going to be 2P2. And if we count up our exponents, 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 2 is 14. That's the number of electrons we need. Oops, that should be a 3P2. All right, so now the question is, how many valence electrons are there? So valence electrons are in the outermost shell. So in electron configuration, the big number, the 1, the 2, the 2, the 3, the 3, that's the shell. So we have the 3 as our valence shell. And there's 2 electrons from the S, 2 electrons in the P. That makes 4 valence electrons total. You add up the superscripts in the valence shell. Which subshells hold these valence electrons? Well, the valence electrons are sitting right here, so the 3S holds them, and the 3P holds them.